Howdy doody. Going to talk to you a minute about your eye. Excuse me. And begin some detail and then leave the rest of it to your reading. So, how does your eye work? What are the principles of vision? Okay, big deal here. Uh, you've all heard questions, or you've thought, or maybe you've asked the questions, whatever, about how far can you see? Well, there are a lot of experiments have been done with this. I know out at sea, if your vision is unimpeded, you have to take into account the curvature of the Earth. Um, Supposedly, the eye is sensitive enough to be able to see. Wow, I'm having a lot of trouble here. Supposedly, you could see a candle 15 miles away. I don't know how they determine that. I don't do that kind of math. But nonetheless, there's a trick question about how far can you see, and the answer is 93 million miles because that's how far the sun is, blah, blah, blah. It's in your textbook, by the way. But all of that's confusing because it makes no sense. Uh, what many people think, and incorrectly so, is that your eyes send out sight rays. And that's not how it works. Uh, what you see, or you don't send out sight rays. You see rays that strike your retina, and then a lot of things happen. So, for instance, when you're looking at an object, let's say you're looking at my motorcycle, um, the perception is not in the motorcycle, it's in your brain. You see light that alters brain activity. So you don't. It's not like radar. You don't know anything about radar. Radar sends out a beam. It hits a target and reflects back to the radar. It reads. The radar antenna reads that. I was radar certified as a police officer, and we had to learn all about the Doppler effect, etc. And the Doppler effect is part of astronomy. If you take an astronomy class, you'll learn about the Doppler effect and the red shift and some other things. So you don't have that happening with your eye. What you have is um, is light striking your eye and the various parts associated with reception of that, and then the interpretation of your brain about what you're seeing. Light enters through an opening in the center of the iris, the pupil. You've all heard of that, and your lens focuses that, and then the lens is adjustable. Goes through the cornea, which is not adjustable, and it's projected onto the retina. That's the rear surface of your eye. And on that part of your eye, there's some visual receptors. So light from the left side of coming into your eyes strikes the right side of the retina, and vice versa. And then light from above strikes bottom, and light from below strikes the top half. So it creates an inversion. So you're looking at something right side up, but when your eyeball takes it in, it's upside down. And the visual system is not duplicating the image, it's coding. And it uses neuronal activity, different kinds of neuronal activity to do it. And then it progresses from that point. You don't send receptor messages directly to the brain. These messages go from receptors at the back of your eye called bipolar cells, and they're located really close to the center of your eye. And they send messages to ganglion cells. Those are located even closer to the center of your eye. And then those cells join together with axons, and they travel to your brain uh, as the optic nerve. So that's where the information, that's their interstate highway. Then you got a lot of little cells involved in this, macrine cells, for example, and it sends information from bipolar cell to bipolar cell, ganglion cells, and other cells. And there's a lot of refining that's taking place. So this is sent through all the way, uh, mainly in the form of shapes and in the form of directions of movement, color, etc., and any other visual features back toward where it winds up in your optical system. Um, some of these cells are transparent, and they're made that way so that light can pass through them without a lot of distortion. But what happens is, at some point in a crossing of the optic nerve, there's a blind spot, and that's where your brain processes information to fill in that blind spot. Now, the blind spot has no receptors, so it can't do anything but pass information along. So if you see something, anytime you see something, you still have that blind spot back there, and it's being taken care of by brain interpretation. If you're last little few details, by the way, when you're looking at a page, when you're reading, for example, when you're studying, you're fixating information into the central part of your retina. There's a part called the fovea. It's a tiny little area, and it's specifically designed for acute, detailed vision. And that vision is probably the clearest vision you have because of the fact that it's unimpeded. It's close to the center. And then there's a lot of receptors. They're packed tightly together, and that helps you, aids you with perception of detail. Also, these fovea connect to a single bipolar cell. I know I'm giving you a lot of cells this and cells that, but you'll be able to read about it too. And those connect to ganglion cells, and that has an axon to the brain. So ganglion cells in the fovea uh, are not only in humans but also in primates, and they're called midget ganglion cells. It's kind of funny, and they're small and respond to just a single cone. So each cone, and we'll get to those in a minute, each cone in the fovea has a direct line to the brain. 70% of the input to your brain goes through this, and your vision is dominated by what you see in or around the fovea. I wish I was in class. I could ask you questions if you get it. So what are we talking about here? We're talking about a system of transmission where you receive light input, and then it goes through this process that um, I've described to you. And then one final thing about the optic nerve, you have an instantaneous memory of what you're seeing. So you have an impression of the scene that's in front of you. And it kind of gives you an idea of what should be a part of that entire picture. If that doesn't make sense, you can read about it in your text, because I want to jump quickly to rods and cones. These are visual receptors. This is what most people hear about when they think about the eye: lens, cornea, retina, rods and cones. Well, here we go. there are two types of receptors, rods and cones in your eye. And they're in the retina. So the rods are in the periphery of a human retina, and those respond to faint light, but they're yet less useful in daylight because bright light bleaches them. You can read about what bleaching means. And then cones, they're in abundance in and near the fovea. They're more useful in bright light, and they're essential for color vision. Everybody knows somebody that's colorblind. Uh, and due to the distribution of rods and cones, we have good color vision if you're normal in the fovea, but not in the periphery. So that gives you an idea of the difference between foveal and peripheral vision. Uh, you have to have good peripheral vision in some uh, professions. Law enforcement uh, requires you to learn how to be aware of your peripheral vision. When I first got into a police car with a training officer to begin my own street training, I couldn't believe how he would see things that I didn't see. And over a short period of time, you just do it. It becomes something that happens almost automatically. So even to this day, I can be in the car with my wife and I'll say, "Did you see that?" She'll say, "What are you talking about?" And I'll point it out to her, and she'll tell me, "I never saw. How'd you see that?" It's just being aware of the peripheral part of your eye. Rods outnumber cones, about 20 to 1. So cones provide about 90% of the brain's input. And remember that they're midget ganglion cells, and they're in the fovea. So each cone has its own line right to your brain. Uh, there are about 120 million rods and about 6 million cones. Um, just give you an idea of what's the physical makeup is. And that's all I want to cover about this, because this, again, a lot of this stuff's pretty complicated. And there's a lot to, obviously, you see that there's a lot to these little systems that we have built into our bodies. So there you go. That's how you see at least a touching the tip of it. And I'll be back with you soon with another one of these little lecturettes. Take it easy.